Okay, well, this is a second part of the Ansys rigid dynamics tutorial. We're going to change one of the members from rigid to flexible and look at the dynamic stresses. So this was the basic model. Again, this is something that's easy to make, easy to see, made specifically to make it clear on how to work the software. So what did we have here? We had for loading we had gravity, acceleration 386.4, and joint displacement. We had joint, the translational joint. We had an X displacement, magnitude, it says tabular, so you'd look over at the tabular data. So in 50 seconds, it went 50 inches. So that's, I think, what else did we have? We had the translational force here as an output. Maybe we'll take a quick look at that, see if that works. Yep. So that, as it's extending, calculates the force on the translational joint to extend that under the just gravity load. So that's really what we did on the previous tutorial. So in order to do a flexible run, we need to get out of mechanical and close that. And initially we did a rigid dynamics run. So now we're going to have to do a transient analysis. So we'll grab those three cells. So we'll use the engineering data, geometry, and the model. So we'll go ahead and open up mechanical again. You don't want to leave mechanical open. You have to close it you know, when you do this switching between rigid dynamics and transient. Okay, so the analysis for time step, so you have to realize now it's, you know, solving the stiffness equation at every step. So we're just going to do, let's see, we want to go 50 seconds to get the full motion, and so I think we'll do it in 50 steps. So we'll just do time steps of 1 second. We'll go ahead and use the same acceleration that we had before. We'll use the same translational joint displacement as we had before. So those are the two loads. And for the output, I guess we can, you know, use the same two that we had before again, but we're really just going to be looking at, yeah, let's go ahead and do the stress, and a von Mises stress. We'll solve for that. Okay, so really, oh, we got to make that joint, this one right here, which was that, let's go to corresponding body and tree. Okay, so that was the pivot arm. So we click on that and we go down here and we can see that it was rigid. So now we'll switch that to flexible. Okay, so we're really ready to do a solve then. So this should take about 5 minutes, so we'll let that crank a little bit. Okay, so it looks like we're complete, and what do we got? So we'll take a look at the stresses, and so it does give the stress contour plot. We'll look at the graph of that. We'll just go ahead and 100 frames and let's say 10 seconds. Kind of animate the, let's increase the color a little bit there. Yeah, okay, see what that looks like. Of course, the critical thing, or the important thing here, is a lot of times in complicated mechanisms you don't know you don't know the statics real clearly, and you may not know the worst case position. So letting it calculate all the positions and viewing this, you can more conveniently zoom in and identify what the worst case position is. And so that's about it. Thanks for watching.